And welcome back. As we continue looking at file, we are now going to shift gears a little bit. Instead of looking at text files, we are now going to look at how to write to binary files. So with binary files, these are files that are going to store data in the same format that is used in the computer's memory to store the values of variables. So a value of type int is stored as the same sequence of bytes or the same sequence of zeros and ones, whether it is stored in an int variable in memory or within a binary file. No conversion of any kind needs to be performed when you store or retrieve a value in a binary file because it's already in the format that the computer is familiar with. This is why binary files can be handled much more efficiently than text files. So let's look at how Java works with these binary files. Java binary files are unlike files in other programming languages in that they're portable, which means they're not necessarily tethered to that particular machine. A binary file created by a Java program can be moved from one computer to another and still be read by a Java program, but only by a Java program. They cannot normally be read with things like a text editor or with a program that has been written in any other language than Java. So that's going to lead us to our conversation on making binary class files. So when we start writing out our own binary files, the preferred streams that we're going to use are going to be the object input stream and the object output stream. Each has its own methods to read or write data one byte at a time. These streams can also automatically convert numbers and characters to bytes that can then be stored in a binary file. They allow your program to be written as if the data is in place in that file or read from the file is not just bytes but also things like strings or items of any Java's primitive data types such as int, char, and double, and even objects of classes that we can define. If you do not need to access your files using an editor, then the easiest, most efficient way to read data from and write data to files is to use binary files, as we're going to demonstrate. So let's look at actually writing to a file. The class object output stream is the preferred stream class for writing to a binary file. Well, how do you use object output stream and object input stream then to read and write objects of any class that we define? An object of the class object output stream has methods to write strings and values of any of the primitive types to a binary file. So let's look at writing some simple data then. Almost all the code for writing to a binary file will, of course, need to be in a try block, and we've seen this with text files. So it's pretty expected. Any part of a code that does binary file I/O, just like text file I/O, in the ways that we're going to be describing, it can throw an I/O exception. So the output stream for writing to a binary file is .dat, so DAT is of course for data, that's our binary format we're going to expect, is created and named with the following. Object output stream equals new object output stream, new file output stream, quote, numbers.dat. Again, it's going to look very familiar to kind of some of the format that we've been using, but it's going to be a little different because you can see we have some different classes, we're using a different file extension. Now let's actually talk about opening that file. Now this is a term we are probably already familiar with because just like with text files, when we actually want to pull that file in, it's called opening the file. And if the file does not exist, well, the statement that we just saw is going to create an empty file named numbers.dat. If the file already exists, well, it's simply just going to erase whatever contents that were in that file so the file starts empty. This situation, of course, as you kind of figured out, is exactly the same as what we dealt with when we had to approach text files, except, of course, as we mentioned, we're using a different class. And as is typical of Java I/O classes, the constructor for the class object output stream takes another I/O class as its argument, in this case, an anonymous argument of the class file output stream. Now, what about actually opening that file for output? What do we need to do? Well, when we create that stream of the class object output stream and connect it to a binary file as follows. All right, object output stream name equals new object output stream, new file output stream file name. The constructor file output stream may throw, of course, a file not found exception, which, if you recall, is a type of I/O exception. If it does succeed, though, in creating that file, then the constructor for the object output stream can, of course, still throw different I/O exceptions. So a single catch block, of course, for I/O exceptions can handle all cases. And then after that file has been opened, you can use the methods of object output stream to write to that file. So let's actually look at those methods that we can use. The first is called writeInt. The class output stream does not have a method named printLine, right? Because we're not printing to a text file, we're not printing to the console, we're writing to a binary file. So we don't have that same text file or screen output that we're familiar with. However, an object of the class object output stream does have a method called writeInt, which can write a single int value to a file, and it has, of course, other output methods as we're going to describe. There are, of course, when we deal with writeInt, no lines or separators between numbers. Instead, the numbers are written in the file one immediately after the other, and they're encoded as a sequence of bytes in the same way that numbers would be encoded in the computer's main memory. These coded int values cannot be read using your editor. You can't just go to the DAT file, open it up, and try to see what numbers are written in here. Realistically, the only way you're going to know what's in there is to open it with another Java program. Now, what about the other primitive types that we might have to deal with? Of course, writeInt sounds good, but what about floats or doubles? Well, you can use a stream from the class object output stream to output values for any primitive type, and also to write data of the type string. Each primitive type has a corresponding write method in the class object output stream. And of course, we've already looked at writeInt for integer values. And if we want to do something similar, well, guess what? We have corresponding methods for those. So, for example, a double, a boolean, and a char are going to have corresponding values such as below. So, object output stream.write double 9.99, output stream.write boolean, false, output stream.write char, parentheses int, and parentheses a. And you'll notice there's something a little different here. We have an int cast in here. Why is that? Well, let's take a look at that. So that write char method, all right, it has a surprising property. It expects its argument to actually be of type int. If you start a value of type char, the char value can be typecast to an int before it's given out to that method. So to output the contents of a char variable named symbol, let's say, you could say output stream.write char, typecasting int around this, and then symbol. You do not need to write in the typecast to an int because Java automatically actually performs it in there. However, it's important for us to kind of recognize why that is the case, though. So if we would just write output stream.write char symbol, it's exactly the same as the one we just saw, just with the typecast removed. It's still going to function exactly the same, but it's important for us to recognize why is there a typecast here in the first place. Well, before we get to that, let's talk a little bit about write UTF for strings. So to output a value of type string, we use the method write UTF. If output stream is a stream of type object output stream, the following would of course write the string hello friend to the file connected to the stream. Output stream.write UTF, quote, hello friend. You may write output of different types to the same file also. So let's say we want to have a combination of int, double, and string values. Yeah, sure, go ahead, you can do that. However, one thing to keep in mind, as we start mixing these file types, it does require special care to make it possible to read them back out of the file. So to read them back, you need to know what is the order in which the various types appear in that file. Because as we're going to kind of start to see as we start getting later into reading in file types, a program that reads the file will use a different method to read data of each type. Now you can close a binary output or input stream the same way that you close a string connected to a text file. We have a .close method to do that. Now I said we need to kind of look at some of those castings. And the reason why we're going to do that is with Unicode. So if you recall, the way Java functions is that it uses the Unicode character set, which is a set of characters that includes many characters used in various languages, whose character sets can be very different from that of English. Now, a lot of times, if you are in an English-speaking country, you're using editors and operating systems that actually use the ASCII character set, which is, of course, again, a kind of standard character set for English-speaking languages and Java programs. Now, the ASCII character set is actually a subset of the Unicode character set. So the Unicode character set has a lot of characters you probably actually don't need in your normal writing. However, it is important to know that this is a very distinct difference. And that is why we have to talk about this, because there's this UTF, all right, UTF coding. The UTF coding scheme is an alternate scheme that still codes Unicode characters, but is actually more favorable towards the ASCII character set. So the UTF coding method gives short and efficient codes to the ASCII characters. Now the price is that it gives long and efficient codes to other Unicode characters. However, because we're probably not going to use the other Unicode characters unless you are, again, a non-English speaking country or it's not your native language, this can be a very favorable trade-off. Now, the method writeUTF does use the UTF coding method to write strings to a binary file. And so let's look at writeUTF in integers, because this is going to be an interesting combination here. The method writeInt, if you recall, writes integers to a file using the same number of bytes, that is the same number of zeros and ones, to store in an integer. The method writeLong uses the same number of bytes, therefore, to store each value of long. WriteInt and writeLong actually use a different number of bytes from each other. The situation is the same for all the other write methods that use primitive types to binary files, so the length of those can vary. However, the method writeUTF has a differing number of bytes to store different strings in a file. And it is pretty acceptable as to why that might be. Longer strings are going to require longer bytes than shorter strings. And so let's bring this all back together. We're talking about Java and UTF. This can, of course, present a typical problem for Java, right? Because there's no separators between data items in a binary file. Well, the way that Java manages to make this work is by writing some extra information at the start of each string. That extra information will tell Java, it's like, hey, here, how many bytes are used to write the string? So when we use readUTF, it knows how many bytes to read and convert. Now, the method readUTF we'll discuss later on, but as you might have guessed, it reads a string value that was written using UTF encoding. So let's bring it back to writeUTF. Notice that we said the information of the start string encoded in the file tells how many bytes to read, but not how many characters are in the string. These two figures are not the same. With UTF way of encoding, different characters are encoded in the different number of bytes. However, all the ASCII characters are stored in just one single byte. And you're undoubtedly using only ASCII characters, unless, of course, I said that you're not using English as your coding language or using something else. So this difference is more on the theoretical side than realistic for what you might encounter. Now, if you go to a broader character set, if you're using more of the broader Unicode character encoding, then yeah, this is something you have to address. And let's just take a real quick look here in Eclipse at a example of how we can use that binary output stream. And you can see my program is very simple looking. We, of course, have our import statements up here. We have a try block right here with our object output stream. And you can see it's writing to numbers.dat. We have an integer called I, which is simply just going to help manage our loop. In fact, I could even put that as a local variable here. I could just call this int I. It's not going to change anything. I can just take that right out, just clean this up even just a little more. And all it's going to do is as it writes through this loop, if you look, it's just writing I. All right, just saying, hey, write 0, 1, 2, 3, etc. And so it says numbers written to the file, and then it's going to close that. Now, if we run this program, all right, it says numbers have been written to the file, and I can come over here and say, I'm going to refresh this file. Let's see, and you see there's numbers.dat. If I try to click that and open it, we get this kind of gibberish here. All right, now of course, it's trying to be helpful here. Hey, do you want to open this file? No, I'm just going to cancel here right now because I'm just trying to demo this. This doesn't look like something that we can normally decipher. In fact, we see these weird symbols and question marks and stuff like that. That's because, again, remember, this is in a binary encoding. It's not in something that we can normally process. Now, if I wanted to see what those numbers I do, and of course, I could just do a system.out.println just to see what is actually being written. I could, of course, just add this in here. If I just, want to do some testing purposes and see what is actually going on here, you can see it's still going to say, oh, here's 0, 1, 2, 3, 4, so I can see what is actually being written to that file. But if I were to try and open that file, I have no way of finding that. Until we, of course, learn how to read in a binary file.